Hi everyone. In this example, we're going to do one more set up your own equation, set up your own quadratic equation to represent this problem, and then find a maximum to answer the question. So this one's got a lot of info floating around. So a lot of this is just about trying to kind of organize that and figure out what our equation involves. So we have a farmer with a 1-acre apple orchard that contains 30 trees. From past records, she knows that her average yield is 400 apples per tree. She's trying to increase the yield of the orchard by planting additional trees. She has some info to help her make this decision. She knows that if she plants one more tree, the trees are more crowded and the average yield will decrease by 10 apples per tree. And based on that, we're supposed to assume that continues for every tree that she adds or takes away. What's going to give her the maximum possible yield for her orchard. Okay, so let's see. You could draw a picture for this one if you want, but I don't know if a picture is necessarily helpful because these don't all split up nicely. So the idea is just she's arranging these trees right now. Okay, so this is our current. She has 30 trees. And she's getting 400 apples per tree. We know that if she adds a tree, she's going to get 10 fewer apples from each tree. So crowding the orchard more is going to reduce the yield per tree. And the question is, how many trees should she plant? How many trees should be in the orchard to get the largest possible yield? Okay, so we are trying to maximize the yield of the orchard. And the yield is the total number of apples, is what I would say. We didn't get a weight thing here. We got a number of apples. So let's say we've been using lots of A's. We'll stick with it. A is the number, let's even say total number of apples from the orchard. Okay, I would say one of the things that's kind of tricky in this problem is actually choosing your other variable. There's a couple of ways that we can do that. And I think one of them is more intuitive as a choice for your variable, but makes the setup slightly messier. So I will show you both ways. Okay, I'm going to go a little further before I jump into that. So I'm going to say, all right, A is the total number of apples from the orchard. The way we would figure that out, so for example, right now, we would take the number of trees and we would multiply by the number of apples per tree. So she's getting 3 times 4, 12, 12,000 apples from her orchard right now. And we want to know what happens as she changes the number of trees and therefore the number of apples per tree. But we can get this started by saying to get the total yield, we would take the number of trees and we would multiply it by the apples per tree. Again, however you want to write this to get you going, this is just your work to get you some setup. So we need a variable that's going to allow us to figure out how many trees and how many apples per tree. And this is where I think there's a couple of ways to approach it. So I'm just going to start with the one that I think most people would think of first, and then I will show you another option just in case it sticks with you and you like it. So I think a really common choice here would be to say, well, let's just let our variable represent the number of trees. That's what's determining how many apples there are on each tree. So let's say T equals the number of trees. Since I don't have a picture to define this in, I'm actually going to write that out. So now I'm looking for A, total number of apples, as a function of the number of trees. So part of this is easy. It's going to be a T times. Part of this is a little tricky. I know that, I'm going to give this a name. Hopefully this won't mix you up. I'm going to call this little a for apples per tree. I know that when T equals 30, little a equals 400. And I also know that if T increases by 1, that A will decrease by 10. So this is the information I'm given about how the number of apples per tree is dependent on the number of trees. what you've got here is a point and a slope. This is a linear relationship. So we've got a slope. We're trying to figure out the number of, I'm sorry, I'm getting it backwards here. The number of apples per tree as a function of the number of trees. So our slope is negative 10 over 1, change in y, which is a's, over change in x. And then we have this point, 3,400. So this, I think, is really good, this right here, because it's really easy to get backwards about which are we thinking of as x and which are we thinking of as y. So just that little visual is kind of helpful. Okay, so we can say that a is equal to negative 10t plus b, and then we can plug in our point to find b. So 400 when there are 30 trees. So 400 equals negative 300 plus b. It looks like b is 700. So basically, this is saying if there are no trees, we should be getting 700 apples per tree. I would say that's getting outside of our reasonable domain. We're not getting any apples if there aren't any trees. But that's what that's giving us. So we're starting with 700 apples per tree, and then it's dropping by 10 for every additional tree we plant. So this is one way to get the setup. I'm going to get an answer, and then I will show you another way that you might think seems slightly easier, but it's a little weirder variable definition. Okay, so now, in fact, I don't want to do anything else with this. My goal was to decide how many trees should be in the orchard if I want to get the largest possible yield. So this one is in factored form, so I would say the intercepts, which basically tell me when a equals 0, so when we're not getting any apples. If there are no trees, we're getting no apples, so that makes a little more sense than over here where we said 700 apples per tree. That's great, but if there are no trees, you still don't have apples. And then this one is saying if t equals 70, we're once again getting no apples. We have 70 trees, but we're not getting any apples from any of the trees because they're so crowded. We're looking for a maximum. We're not looking for the zeros. So the maximum should be right smack in the middle. And it looks like if we plant 35 trees, we will get maximum possible yield from the orchard based on the information given. Okay, so that's option number 1. I will show you option number 2 if you're interested in it. It's pretty easy setup, but it is kind of a weird definition. Another way to do this is instead of choosing t to be the total number of trees, and in fact, let me just sneak that up here so we're clear. That's the total number of trees in the orchard. We could, here, let me pick a color. We could instead, from right here, say, okay, well, one way to look at this is that the total number of trees and the number of apples per tree are both fairly easy to relate back how many trees we add to the orchard. So I'm going to use a little t for number of additional trees. Or it could be trees that we take away. So a negative t would imply that we should take trees away. So again, I think that's kind of a trickier definition to come up with. I don't think as many people will think to do that. But if you remember, it does make the setup a little easier. You don't have to do that linear work off to the side. You can just say, okay, well, if I'm looking for the total number of trees, I started with 30 trees, and I'm saying that I'm adding t. So there are 30 plus t trees in the orchard. If I'm looking at the number of apples per tree, I was getting 400 apples per tree, but that's going to drop by 10 for every single tree I add. So I need to take the number of trees I added, multiply by 10, and subtract that from 400. So I do think this leads to an easier setup, but again, it's a matter of, do you remember this slightly tricky way of defining your variable? If you do that, it makes life a little easier. This will lead to one extra step at the end, but it's not a terrible step. So now if I'm looking for the maximum, I once again have a factored form. So I would say we get zeros if t equals negative 30. So again, these are the intercepts. Okay, so if t equals negative 30, basically if we take all the trees away, then we're not going to get any apples. Or if t equals 40, So we add 40 trees to the orchard, we're not going to get any apples. The maximum should be right smack in the middle of those two. So at little t equals, that's a total of, okay, so these are 70 apart, which means the middle is going to be 35 away from either end. So if t equals 5, the units on this are trees, but we have to be careful because that I don't think quite answers the question. The question was how many trees should be in the orchard, and this is saying we should add 5 trees. So you do still have to do a little bit of work to get the 35 trees, not hard work, but just remember 35 trees total in the orchard. So it will get you the same answer, and I do kind of like the setup, but it is a little bit weird on the variable definition. All right, that's it. Thanks for watching.